Okay, let us predict the product for the following reaction. So first reaction we have. So this is the exercise of remembering the reaction. So secondary butyl isopropyl ether. So you have one side secondary butyl group that is attached, another side that is isopropyl group is attached. The question says, let me write sec butyl isopropyl ether plus conc HBr and heat, and this solution is also heated. So what will be the final product? So first write on the structure of sec butyl isopropyl ether. One side you will have sec butyl group, another side you will have isopropyl group. So oxygen you have one side, let us say isopropyl, so CCH3, here you have CH3, CH3, so this group is isopropyl group. Now this side you will have a secondary butyl, so you have 4 carbon, 1, 2, and so you will have this molecule. So this is secondary butyl because this carbon is secondary carbon. This is tied to this carbon, this is also attached to this carbon. So this is a sec butyl group. So let me write CH3, CH2, CH3, here you have hydrogen. Now if I treat with HBr, what product you expect? So this is the ether, and this ether is cleaved by HBr. So what will happen? H plus will go here, and this bond will break. Either this side you can break, or you have other option, you can break this side. So any one you can do. If you break this side, so Br will attack here, or if you break from this side, you will have Br here. So let me break from this side first. So I will have CH3, CH2, CH, and Br will be here, and CH3. So I have basically broken this bond. So along this bond I have broken, and now this side I will have OH, CH3, CH, and then I will have CH3 here and OH. But now since there is heating also given, so this alcohol will basically form alkene. Dehydration of alcohol will take place, and this will form alkene because mixture is heated. CH3C double bond, CH double bond, CH2. But in solution, if you have excess HBr, this alkene will further react with HBr. H plus will attack here and Br will attack here. So we will have CH3, CH, Br, CH3. Are you getting? So finally you are getting two things. You are getting this compound as well as this compound. So you will get these two compounds. Are you getting? And one molecule of water will be lost from here. So this is a dehydration, alkene plus H2O. Are you getting? So you will get this product, one alkyl halide. This is another alkyl halide. You will get. I think all of you are able to understand. So this is a ether cleavage. Now let us discuss the next part. So B part of the question says tert butyl ethyl ether. So you have tert butyl ethyl ether, and then conc HBr and heat. So you have to draw the product yourself. In this case again, this is tert butyl ethyl. So on one side you have ethyl group, another side you will have tert butyl group. Okay, let me write this one. So you will have ethyl one side, CH2, CH3, one side ethyl group you will have. Another side you will have tert butyl group, CH3, CH3, CH3. Now if you add HBr, the same reaction. H plus will add here, and then I have to break from this side because carbocation that is formed is stable. So I will have this side Br and this side OH. So first product I will get CH3, 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 and here I will have Br, and then this side I will have OH. So OH, CH2 CH3. But this will also go dehydration easily because the solution is heated, and after dehydration you can add HBr, or other way around you can make H2O plus, you leave H2O and add Br here. So after this heating and HBr, it will react and you will have CH2 CH3, and here you will have Br. You're getting around. You can do two things. You can make alkene and then add HBr, or you protonate this HOH and make good leaving group. H2O goes and Br attacks. So you will have this compound. One this compound you will get, another this compound you will get. So these are the two products you will have in this reaction. So if you have written, then I can go for the C part. So C question says di and butyl ether. So you have di and butyl ether. This means both sides you will have butyl group, and this react with hot conc NaOH. Hot conc NaOH. So what will happen in this case? So first let me write di and butyl ether. You can draw the structure yourself. So you will have oxygen, and both sides will have butyl group. So CH2 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 CH3. So this is one. This side also you will have CH2 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 CH3. So this is di and butyl ether. Now if I do react with NaOH, what will happen? Any idea? Okay, in this case there will be no reaction that will take place. So you have a ether. Ether can be cleaved only in acidic medium. Now the medium is basic, so ether cannot be cleaved in basic medium. This is the important point. You can write ether can be cleaved. Ether can be cleaved only in acidic medium. In basic medium there is no cleavage. Only in acidic medium. Either you can take HBr, or you can take HCl, or you can take HI, and you can cleave the ether. If you have done this one, then I can go for the next one. So let us copy fast. So let us say you have the next reaction. This reaction also you have to remember. So you have D part. This time you have di-n-butyl ether plus sodium ether. So let me write di-n-butyl ether. So this is CH2 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 CH3. This side also you have the same thing, CH2 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 CH3, di-n-butyl ether. And if I treat this with sodium ether, what will be the product? Can you think what sodium metal does? Sodium metal basically looks for acidic hydrogen. So if you have alcohol, it can take acidic hydrogen. Now you can tell me what should be the reaction in this case. We have given enough information. That is, sodium metal looks for acidic hydrogen. Yeah, good. In this case there is no acidic hydrogen, so once again there will be no reaction in this case. Sodium metal basically looks for acidic hydrogen. There is no acidic hydrogen, so this reaction will also not take place. So no acidic hydrogen. That's why this reaction will also not take place. So let us discuss F part. So this says E, first E, ethoxybenzene and HI heat. So you have ethoxybenzene, something like this. O CH2 CH3. So this is ethoxy group, and this side you have benzene group. So this is ethoxybenzene. So I can name this one something like ethoxybenzene. Now if this react with HI and heating also is given, what will be the product? This is again cleavage of ether. Now the medium is acidic, it can be cleaved. So let us write the product. Now this is a slightly tricky one. Now see what will happen in this case. First case you will have OH plus, you will have CH2 CH3. So Hi will give H plus. Now you have I minus. I minus has two options. Either it can attack on this carbon and this goes. So this is one option A. I minus basically have another option also. OH CH2 CH3, and I minus can also do the another thing. So this I minus have is the next option. So it can either attack even on this carbon and this goes. Now you have to tell me which path will happen. Either path A is more favorable or path B is more favorable. But what do you say? Yeah, in this case you are attacking a carbon, that is a benzylic carbon, a phenylic carbon you can say. On this carbon nucleophilic attack does not take place. We have already discussed in the class. This carbon is sp2 hybridized, so sp2 hybridized carbon nucleophilic attack does not take place. So this reaction will not take place. This is a primary carbon, secondary of course, this is a secondary carbon. So on this it can attack and this can go. So on this carbon nucleophilic attack will take place. So you will have this two product OH, and this side you will have CH3, CH2, and iodine will be attached. Are you getting? So simple. So whenever you have a phenylic ring or benzene ring, on benzene ring nucleophilic attack will not take place. Nucleophilic attack takes place in the other part of the molecule. So let us say F. If I discuss F, so what this says, 1,2-epoxyhexane H plus and CH3OH. So you have a epoxy group at 1,2 position in hexane. So you have 1, 2, 3, 4, 5, 6, and position number 1, 2 you have a epoxy. So this is COC. So this group is called epoxy group. So epoxide. And 1, 2 epoxyhexane H plus and CH3OH. So now you have H plus CH3OH. So what will happen in this case? Now you know the answer. So what will happen in the first step? It will react with H plus. So let me write down the mechanism 1, 2, 3, 4, 5, 6. Now first step you will have OH plus. Are you getting? Now in the next step nucleophile will be CH3OH. So CH3OH itself will act as a nucleophile because no other nucleophile we have in the solution. Now it has two options. It can attack on this carbon or it can attack on this carbon. So if this opens, the carbocation will form, that is secondary in nature, and that's why you have to open this one. If I open this, carbocation is formed as primary. So if I open this, carbocation formed is secondary in nature, and same time this can attack here, and the same time H plus can be lost. Are you getting or not? So in this case the product will be 1, 2, 3, 4, 5, 6. Carbon number 1 you will have OH group attached, and carbon number 2 you will have OCH3 group attached. Now let us say Z part. So what this Z says, trans 2,3-epoxy octane H plus H2O. So you have a trans 2,3-epoxy octane. So you have 8 carbon. 1, 2, 3, 4, 5, 6, 7, 8. And on position number 2, 3 you have a oxygen. So 2, 3, 1, 2, 3. So 2, 3, 4, 5, 6, 7, 8. So on carbon number 2, 3 you have a epoxy group. And this is a trans. This means that both these hydrogen are opposite to each other. So I can make something like this. So let us say I can use this kind of diagram. So C, oxygen is here, C, oxygen is here. Now one hydrogen is going in here and one hydrogen is going in, and there I will have something like this. Are you getting? So let us make slightly bigger. So on this, so this is trans, so hydrogen should be opposite. One hydrogen is this side, another hydrogen. This side you have CH3, and this side will have CH2, CH2, CH2. So 1, 2, 3, 4 CH2 and CH3. So 4 CH2 you will have, and then you will have CH3. Are you getting? Now if I do hydrolysis, if this reacts with H plus H2, things are easy. H plus will go here, so OH plus it will form. If I open from this side, the carbocation I will get from this side secondary. If I open from this side, again carbocation will get is secondary, and H2O can attack. So H2O can basically attack on this carbocation, or it can even attack on this carbocation. So I will get two product. Because both are getting on secondary, and the stability difference is not too much, because this will be more because of the inductive effect for this. This will be less because of the inductive effect of this. So if I let us say attack on this carbon, H2O will attack, and if H2O loses H plus, so finally OH will attack, and this open this side. So what you will have? You will have on this carbon one OH is downside, on this carbon OH is upside. And what will happen? So this group will come down, CH2O4 CH3, and this carbon that is also coming down. So this is hydrogen. Here we'll have CH2O4 CH3. Are you getting? On this carbon, this CH3 is below side but slightly up. This hydrogen is again forward side but slightly up. So this is the one product. OH and this are basically trans to each other. If you want, you can write other product also, and that other product will be formed. On this OH will be top, and on this OH will be down, because H2O can also attack on this carbon from this side. This ring can open from this side. So in other case, this OH will go up, this OH will go down. Are you getting or not? So you can write down the other product also. Okay, we'll discuss the next problem. So let us copy this one first, and then we can go for the next one. So this is a epoxide ring opening of epoxide ring. So acid catalyzed opening we have discussed in the class, and there is a base catalyzed opening. In acid catalyzed opening, carbocation like intermediate is formed, and in this case again attack happens always from the back side, and three-membered ring opens, and this so attack is anti in nature. We'll discuss the next problem.